Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Docker Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to take a look at slope and equations of tangent and normal lines at a particular point. So these are the first set of problems that we want to look at, and after this lesson, we will look at additional problems as well. So the first thing we want to know, what is a tangent line and what is a normal line? We will also explain what is a secant line. So a tangent line is a line that touches a curve at a single point. And that point, we refer to that point as the point of tangency. And also a normal line is a line that is perpendicular to the tangent line at a point of tangency. So assume we have this graph. There's a graph, for instance. So if there is a point right here, if there is a point right there, and if we run a line through this point, a line that is exact, that is touching this point only, this line is called the tangent line. This line is called the tangent line. And then this particular point is called the point of tangency. So this is a tangent line. It touches a curve at a single point. Next, we have the normal line. Now, if a line runs through this point of tangency on this curve and forms 90 degrees, that line is called a normal line. So if we have a line like this that runs through this, and then this line forms 90 degrees with this tangent line, that particular line is called a normal line. So this line is called normal line. Also, when a line touches 2 points on a curve, when this line touches this point and also touches this point, that is, it touches 2 points on this curve, so when this line touches 2 points on this particular curve, this particular line is referred to as a secant line. So, in summary, a tangent line is a line that touches a single point on a curve. A normal line is a line that is perpendicular to the tangent line at the point of tangency. And a secant line is a line that touches 2 points, any 2 points on a curve. So with that being said, we want to look at these examples. So let's look at the first problem. So we were asked to find the equation of the tangent line and the normal line for each of these equations. So the first one says y equals x cubed minus 2x squared plus 4 at the point of tangency is 2, 4. So we know that the equation of a line at a point is given by y equals to mx plus b. So an equation of a line at a particular point is given by y equals to mx plus b, where m is the slope and this b is the y-intercept. That is, m is equals to the slope and b is the y-intercept. But under differentiation, the slope m is also the derivative. So the first derivative is the slope, or we also call it in physics the velocity. And the second derivative is the acceleration. So since the first derivative is the slope, to find the equation of this line, we must first find the first derivative. So we must first find the slope, m, which is y prime. So we differentiate each term, the derivative of x cubed, using the power rule. We drop this power 3. We rewrite x and subtract 1 from this power. That's a rule. So 3 minus 1 is 2. Minus 2. 2 times 2 is 4. Rewrite x and subtract 1 from this 2. We're left with 1. The derivative of a constant, we know that is equal to 0. So now we have gotten the first derivative, which is the slope. But we want the slope to be a particular value instead of it being in this form, like a function. We want it to be like a value. So since we were given a particular point, 2, 4, which is the point of tangency, we know that for every order pair, the first term is x and the second represents y. So wherever we see x, we're going to replace it with 2. So it means the slope now would just be 3 times 2 square minus 4 times 2. So 2 raised to the second power means 2 times 2 times is 3 minus 2 times 4 is 8. So 3 times 2 is 6, and then 6 times 2 is 12. Or you say 2 times 2 is 4, 4 times 3 is 12. So it's 12 minus 8, which is just equals to 4. So the slope is equals to 4. That is, m is equals to 4. So we already have an equation where the slope is already equal to 4. We already know the slope. So we can write the equation as y equals to mx plus b. Y, m now is 4m plus b. But we need to find this b. So sorry, it's 4x. We need to find this b. So in order to find this b, we must replace the value of x because we already know that x is equal to 2. So we say y is equal to 4 times 2 plus b. But what is this y? This y is 4. So now we can simplify. So we have 4. Now this 4 times 2 is 8. If we send it across, it becomes minus 8. So b will just be equal to, equals to minus 4. So if b is equals to minus 4, we can now find the equation of a tangent line. That is y equals, we know m to be 4, x, and then this b now, we know that it's minus 4. So you could just simplify it like 4 outside, x minus 1. So this is the equation of a tangent line. at the point 2, 4. So the equation of a tangent line will change based upon the point of tangency. If this point changes to, for instance, 1, 1, this equation is going to change. Now, this is how we find the equation of a tangent line. Let's now determine the equation of the normal line. Now we know that the slope is equals to 4. That's what we know. But since we were told initially that a normal line is a line that intersects the tangent line at the point of tangency, forming 90 degrees, that means we have two lines that are perpendicular to each other, which is the tangent line is perpendicular to the normal line. Now, in our previous lessons on algebra, we told you that when two lines are perpendicular, the product of their slopes, that is, if you have the M1 for the first line and you have M2 for the second line, the product of these two slopes will be equals to -1. So if we know M1 to be 4, for instance, if we know M1 to be 4, 4M2 equals to -1, it means that M2 now will be -1/4. So for short, we just say the slope of the normal line is like the reverse of this particular slope, and then with a negative sign attached to it. But this is how we calculate the slope of the other line where two lines are perpendicular. When two lines are parallel, their slopes are equal. So if these two lines were parallel, it means this slope, the slope of the tangent line will be equal to the slope of the normal line if the normal line was parallel to the tangent line. So since we know now that the slope of this normal line is -1/4, we can now determine the slope of the normal line. So what's the equation? Oh, we erase the equation. Okay, so now we have y equals to mx plus b. So we know that our m now is -1/4 x, and x, we know that x is equals to 2, right? This is 2. And then y is equals to 4. We want to find b. So we can just multiply this whole thing by 4 to get rid of this denominator. 4 times 4 is 16. 4 times this, 4 and 4 will cancel. You left with -2 plus 4b. So we send this 2 across. It becomes +2 or equals 4b. So we can divide all sides by 4. So 16 plus this 2 gives us 18, right, over 4, or equals to b. 2 here, 2 times 2 into this goes there 9 times. So b is equals to 9/2. So if b is 9/2, we can now determine the equation. So we can now determine the equation of the normal line. So this particular curve, right? So this will give us y equals to mx plus b. Y is the variable in the equation. X is the variable in the equation. Our aim was to just find m and b. So we already got the m from the derivative, which is now -1/4. So m is -1/4 x, plus b now is 9/2. So we can just multiply this whole thing by the LCD, which is 4. 4 times y is 4y. 4 times this expression, 4 and 4 will cancel. You're left with -x. And then 4 times 9 Now 2 goes here 1 times, 2 goes in the 4 2 times. So 2 times 9 is just 18. So this is our final answer. We can just divide both sides by 4 if we wish to just solve for y. We can divide both sides by 4. If we don't, we can just leave it as it is. But since we chose to divide both sides by 4, we can have minus x plus 18 divided by 4. So either of these is referred to as the equation of the normal line at this particular point 2 and positive 4. So let's do the next one. So this is how we solve for the equation of a tangent line and the equation of a normal line of a curve at a particular point. So the second problem says x squared plus 3xy plus y to the second power all equals to 5 at 1, 1. So there's the point of tangency. So we first find the derivative. Those are the things that we must find. The derivative, which is the slope, and we also need to find b from the equation mx plus b equals to y. So we want to find m first. We know that m is equals to the slope, the derivative of this expression. So let's find the derivative. Differentiate x squared, we get 2x plus, now you have 3xy. Because you have two expressions being multiplied by each other, we must apply the product rule, right? So we can hold this 3, and the product rule says hold one of the factor x, differentiate the other. So the derivative of y is just 1, but because y is the name of this function, we attach y prime plus, we hold y now, and then we differentiate x, we get 1 plus y squared. So we differentiate y, gives us 2y, and we attach y prime to it. The derivative of 5 gives us 0. So we can group all of the terms of y prime on one side of the equation so that we'll be able to solve for y prime. So we have 2x plus 3x y prime, 3 times y, 3y plus 2y y prime equals to 0. So these are the two terms with y prime. We group them. So this is y prime. So 3x, we have 3x, and then 2y plus 2y. The other terms, we send it across the equal sign. We have minus 2x minus 3y. So we can divide both sides by this expression, which is 3x plus 2y. Divide this out as well. 3x plus 2y. So this and this will cancel. We'll be left with y prime is equal to, so if we factor out negative, we'll have negative 2x, negative is outside, negative 2x plus 3y divided by 3x plus 2y. So this cannot cancel this because you have 2x and then you have 3x, so you cannot cancel this too. So this is called our slope. This is our slope. So now since we know that y is 1, x is 1, y is 1, we can replace x and y. So the slope now equals to 2 times 1 plus 3 times 1 all over 3 times 1 plus 2 times 1. So this is 2 plus 3, and this is 3 plus 2. So we have 5 all over 5 is equal to 1. So the slope is just equal to 1. So this is our first slope. For the tangent line, this is the first slope, m. So we know that the product of two slopes, m1 times m2, must be equal to minus 1. So if m1 is just 1, then it means m2 will also be minus 1. Because if you just put 1 here, 1 times m2 is m2. So this now becomes the slope for the normal line that we'll use later. And this is the slope for the tangent line. So we now want to find the equation of both the normal line and the tangent line. So equation of tangent line So we have y equals to mx plus b. So what is m? M is just 1. So 1 times x is just x plus b. But we need to know what is this b. So we replace x and y. So x and y is just 1, 1 plus b. So it means b will be equal to 0 because if we send this 1 across, it becomes 0. So b is equal to 0. So therefore, y is equals to mx. But this m now is 1, so it's just x. So y is equal to x. So there's the equation of the tangent line. The equation of a normal line the normal line will be y equals to mx plus b. So we first find our b. So this is y1. The slope now is minus 1 for the normal line. So it's minus x plus b. So if this minus 1. Because the slope is minus 1, and then x is also positive 1, so it's just minus 1. So if this minus 1 goes across, it becomes positive 1. So b is equals to 2. So if b is 2 now, we just have y equals to m, which is minus x plus b is now 2. So this is how we find the equation of a normal line and a tangent line. So let's see if you have these two lines. Let's see as to whether they are actually perpendicular to each other. This is the tangent line, y equals to x. So we can find some value so that we graph it. So we say x is 0. When x is 0, y will be 0. When x is 1, y will be 1. When x is minus 1, y will be minus 1. When x is minus 2, y will be minus 2. When x is 2, y will be 2. And then the next one, normal line. So let's find values. So it's y equals to minus x plus 2, x and y. So when x is 0, y will be 2. Let's look for values that would not make this y to be very big. So when x is positive 1, y will be positive 1, so it's minus 1 plus 2, y will be 1. When x is positive 2, or you replace this with positive 2, so you have 0. When x is minus 1, minus and minus is positive, so it will be 3, and so forth. So let's not deal with too many values. So if we have this equation, these two equations, and then we want to graph them, we can have some values on the x and the y axis depending on the few values that we got. So we got these values 0, 1, 2, minus 1. So we don't have to list too many values. Minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4. On the y-axis, we have the highest number to be 3 and the lowest number to be minus 2. So the highest number is 3. So we just have few values, 1, 2, and 3, not too many. 1, 2, 3, 4, for instance. And then this we have minus 1 and minus 2. So we plot. For the first equation, when x is 0, y is 0. When x is 0, y is 0. When x is 1, y is 1. When x is 1, y is 1. So it's somewhere around here. When x is minus 1, y is minus 1. When x is minus 1, y is minus 1. Somewhere around here. Oh, minus 1, sorry, down. When x is minus 2, y is minus 2. Minus 2, minus 2. So this is how it's just going to be, just going to be extending and so forth. So we run a line between it. So we're going to have a line like this for y is equals to x, which is a tangent line. So if a curve was, if you had a curve, this equation, if this equation was graphed, it means that y will be, let's say this equation, this tangent line will be touching the curve, right, at the point 1, 1. So at this particular point, this is exactly where you will have the curve. Probably if it was a curve like this, it will be touching this particular tangent line at this particular point, 1, 1. So this is the point of tangency. So now, for the normal line, when x is 0, y is 2. When x is 0, y is positive 2. This is positive 2. When x is 1, y is 1. X is 1, y is 1. When x is 2, so you see that this will intercept at this point of tangency. When x is 2, y is 0. This is 2, y is 0. So you don't even need more. When x is minus 1, y is 3. Minus 1, y is 3. So somewhere around here. So you don't need all of the points in the word because you cannot even finish all of them. So you just use these few points and you see that. So we clearly see that this normal line is perpendicular. This is the normal line. Is perpendicular. It's perpendicular toward the point of tangency. This is it right there. Okay, so let's solve the last problem under this. If you have any question at any time, don't hesitate. Just ask your question in the comment section and I will respond to you immediately. So the last question under this lesson is x squared minus y squared equals to 7 at the point 4 minus 3. So we first find the slope, which is the derivative. Differentiate x squared, we get 2x. Differentiate y squared, we get 2y. And then we attach y prime equals, the derivative of a number is equal to 0. Just a number standing alone is equal to 0. So we need to solve for this y prime. So we send this 2x across. So this is minus 2y, y prime equals, so the sign will change to negative 2x. So again, you can multiply all sides by minus 1. You will have positive 2y, y prime equals 2x. So we can divide all sides by 2y and 2y. So y prime, which is also the slope, will just be equal to x over y. So we can determine the value of the slope by replacing x and y, which is 4, and then this is minus 3. But this is x and this is y. So this is the slope for the tangent line. So we know that when two lines are perpendicular, m1 and m2 is just equals to minus 1. So if m1 is minus 4 over 3 times m2, it means we can solve for m2. So we can multiply all sides by minus what? So we say minus, to get rid of this negative, we attach a negative. To get rid of 4 over 3, we can say 3 over 4. So we multiply negative times negative gives us positive. So it's positive. So 3 and this 3 will go out. 4 and this 4 will also go out. So you just have M2. So negative times this negative is also positive. 3 over 4 times 1 is just 3 over 4. So this is the slope for the normal line. So we're going to find the equation of both lines using those slopes. Oh, the first one was, I think it was 4 over 3. Okay. So we know that M1 is equals to 4 over 3. That's what we got. Okay. 4 over 3. 4 over 3. Yes. So we can even prove it. Because this M1, this minus 4 over 3. This was minus 4 over 3. Because if this is M1, we multiply it by this, we need to say 3 over 4 times. Okay. So that's it. So let's find the equation now. Y equals to mx plus b. So y now is 4, is minus 3. This is the point of tangency. So y is minus 3. And m, we found m to be minus 4 over 3. And then x is 4 plus b. So we can multiply all sides by 3 to get rid of this 3 down here. Or we just send this one across. Let's just do it that way. So we have minus 3. 4 times 4 is 16. 16 goes across. It becomes positive 16 over 3 equals to b. So we can say 3 times 3 is 9. So it's 9 minus 9 plus 16 over 3. All equals to b. So minus 9 plus 16, the signs are different. We subtract. So we're taking 9 from 16. So if 9 leaves from 16, we'll be left with 7. Because 7 plus 9 gives us 16. So we will have positive 7 over 3 equals to b. So if this is b, we can now find the equation of the tangent line. So we have y equals, the slope is minus 4 over 3. X is 4. So we don't have to replace x again because x and y are the variables within the problem. And then plus b now is 7 over 3. So you can do it either way to get rid of these denominators. So we can multiply all sides by 3. So we have 3y equals to 3 times this term. 3 and 3 will cancel. You have minus 4x. 3 and 3 will also cancel. You have plus 7. You can do it like this. Or you can say, okay, so I'm not going to multiply all sides by 3. I'm just going to simplify this one. You will just have your y to be equal to, the LCD is 3, or denominators are the same. We take one of them and add the numerators. So you just have minus 4x plus 7. So whatever way you want your final answer to be in, you can rewrite it in that form. So we find the equation now of the normal line. So y equals mx plus b. What we need to find is just our b, because we already know m to be 3 over 4. And we got 3 over 4 from the first slope. Since the two slopes are perpendicular, the product of their slopes must be equal to minus 1. So we said m1 is minus 4 over 3 times m2 minus 1. To get rid of this, we must multiply all sides by minus 3 over 4, the reciprocal, right, of this one. So if we say this time, this 3 and 3 cancel, 4 and 4 cancel, we just left with m2. And then this time, this is also positive. That was how we got 3 over 4. So y now equals, so since we want to solve for b, we can replace y and x using the same point of tangency. So it's minus 3. And okay. Oh, sorry. So this minus 3. And then this m is 3 over 4. And our x now is 4 plus b. So this and this cancel. So this 3, if this 3 goes across, it becomes minus 3. So it's minus 3, minus 3. So b is just equal to minus 6. So if b is minus 6, we can now replace. So we have y equals mx plus b. So y is, m is 3 over 4. And then this x, we rewrite x. And then b now is just minus 6. So this is the equation of the tangent line or the normal line. Or we could say, since we want to get rid of this denominator, multiply all sides by 4. So it will be 4y. 4 times this, 4 and 4 we cancel, you left with 3x. 4 and 4 times this, we just give you 24. So whatever way you want to go, it's up to you. So thanks ever so much for watching. And please subscribe to our YouTube channel, watch previous lessons, and like the video. You can share the video as well. Hit the notification button so that when we come out with new videos, you can at least have knowledge that yes, there's a new video that is up. So thanks ever so much, and see you in our next lecture.